I would suggest that you pause the video and try this warm-up. So it's saying that if g of x equals negative 2x squared plus 5x, evaluate each of the following. So first g of 1, and then g of negative x plus 7. All right, so hopefully you did that, and you should have gotten, for the first part, you should have gotten g of 1 equals 3. And then for part B, g of the quantity negative x plus 7 is negative 2x squared plus 23x minus 63. So today we are going to still continue in section 2.1, which is still basics of functions and their graphs. Today we're going to obtain information about a function from its graph. We're going to identify the domain and range of a function from its graph, and we can identify intercepts from a graph or from a function's graph. So, obtaining information from graphs. You can obtain information about a function from its graph. At the right or left of a graph, you will find closed dots, open dots, or arrows. So each of those represent different things. So let's talk about what they mean. A closed dot indicates that the graph does not extend beyond this point and the point belongs to the graph. So a closed shaded dot. The dot does not extend beyond that point. The point belongs to the graph. If we have an open dot, so an open circle, it's not shaded, that indicates the graph does not extend beyond that point and the point does not belong to the graph. If we have an arrow, that indicates the graph extends indefinitely in the direction for which the arrow points. All right, so obtaining information. Notice that in this picture, I see from this function, I see a closed dot on the left, I see a closed dot on the right. So I know that those points, whatever those ordered pairs are, they are a part of the graph, but they don't extend beyond those points. Just like we talked about yesterday, remember, domain deals with our x values and range deals with our y values. So we're going to find the domain and range from the following graphs. We'll write our answer in interval notation. So notice that we always read a graph from left to right. And so remember, interval notation, we want to go from smallest number to biggest number, from the left to the right. So what I see on the left of this first graph is I see a closed dot. That means that that point is included. And if we're talking about the domain, remember, domain deals with our x value. So I want to look to see what is the x value at that closed dot. So if I look down, that happens to be at -2. And since it's a closed dot, that means it's included. And remember, including means we want that bracket. So -2. If we go to the right-hand side, notice that the graph stops at that open circle. And if I look at the x value, that happens to be a 1. But because that circle is open, it does not include it, which means we want a parenthesis. So there's my domain. If I look at the range, which is the y values, I want to go from the lowest up to the highest. So I start at the bottom. Notice that the graph dips down here on the y at 1. And it's on it. Notice how it doesn't have open or closed circles particularly at that, but since the graph is connected through it, that means that it is including it. So that means that I am going to have a bracket. It starts at 1. That's the lowest y value. If I go up, the highest value for y looks like it's 5, and that's at that closed circle. And so closed circle means that we include it, so we want a bracket. Okay, if we look at the next function, once again, I read them from left to right. So if we're talking about domain, I'm looking at the left-hand side first, and I see that I have an arrow. And so because the arrow is extending to the left, that means that all of the x values to the left just keep going and going and going. That means that it's heading towards -infinity. So now if I go to the right, well, where does it stop on the x's? It stops at 4. And notice that that is a closed circle, so that means we want a bracket. If I'm looking at the range, once again, we're looking from the lowest y value up to the highest y value. So if I'm looking at y, it is going to be 0. Notice that that point is at 4, 0. So it's including it. So 0 is my smallest y value. As far as my y value, it's going to extend higher and higher and higher because of that arrow on the left. So while the arrow is heading towards the left, it's also heading up. And so that means it's heading up towards infinity for the range. All right, so now let's look at this graph. It says use the graph on the right to answer the following questions. We want to find f of -1. So here we're evaluating using the picture. So remember, this is the x value. What we're trying to do is we're trying to find the y value. So I go over to -1 on the x, and I find where the function is located at -1. Well, it's located up here, and if I look at the y, that happens to be at 2. So f of -1 equals 2. In part B, it says find the values of x for which f of x equals -1. So this time, they're actually giving me the y value, and they want me to find the x value. So on the y-axis, I go to -1, and notice that if I'm looking from left to right, there's actually 2 different spots where my graph is going to have y be -1. So on the left-hand side, my x value, it's not the clearest x value, so I'm going to have to kind of estimate it. It's not quite halfway between -2 and -3, so I'm going to say that it's roughly -2.25, so -2.25. Okay, if I look at the right-hand side, notice that at -1, it is going to be here at when x is 4. So sometimes you may have more than one value, and that is perfectly fine. So we have 2 different values there for which the function equals -1. If I want to find the domain, remember, domain is the x values. You go from the left to the right. So if I start on the left, the farthest left would be at -3. And notice that it is a open circle at that -3. So that means I want a parenthesis. Then I'm looking farthest on the right. I see it stops at the x value of 6. It is a closed circle, so that means it is a bracket. As far as the range goes, the lowest it is for the y is dealing with that open circle, and that happens to be at -4. So that means we get a parenthesis there. Where is the function the highest? Well, if I look on the y-axis, it looks like up here at 4 is where it peaks. And so at 4, because that graph is, it's moving along there, there's no open circles anywhere, that's including it, so we'll have a bracket. In part E, when it says to find the x-intercepts, we are looking for all of the values where it's touching the x-axis. So notice that there are 3 points, and I'm going to list those as ordered pairs. So we've got the ordered pair -2, 0. We've got the ordered pair 3, 0. And we've got the ordered pair 5, 0. If I want to find the y-intercepts, we're looking for where does it touch the y-axis. It looks like it touches it at 1 spot. I'm going to write it as an ordered pair. It's touching at 0, 3. Let's take a look at another example. Use the graph to the right to answer the following questions. Part A says find the values of x for which f of x equals 3. So remember, that means that we are given the value for y. I want to find all of the x values that y then equals 3. So if I'm looking at my graph, I'm going to highlight it. Notice that here's 3. So I'm going to do this. So that's where all the y's are 3. So notice that when I highlighted it, it actually touched the function at 2 different spots. So we just want to figure out what those x values are. So notice that on the left, the farthest would be at -1, -2, -3, it looks like. So -3 is one of the values of x that gets us then our function y to be 3. The second spot then is when x is 0. If I want to find the domain, we're dealing with our x values. So going from left to right, notice that on the closed dot on the left, it looks like -4 is at that spot. And since it's a closed dot, I know that I want a bracket to include it. Then on the right, it looks like we have an open circle that stops at 3. An open circle means that we want a parenthesis because it's not included. If I'm looking at my range going from lowest to highest, well, it looks like at 0, that is going to be the lowest. And I know that there's an open circle there, but notice how there's also this horizontal line, and there are points that are included on that line. And so I am going to be able to include 0 in my range. So I will have a bracket there. If I look at the highest point for the y, looks like up here at that closed dot on the left is the highest, and that is at 5. And so once again, since that's included, I want a bracket. If we look at this picture, we're going to identify these things. So the first thing we want to find is the function at 4. So once again, this is my x value. So I have to go over to 4 on the x-axis and then figure out what that ordered pair is. Well, if I highlight it in blue here, notice that it's this point right here. And so that's when y is 3. So f of 4 equals 3. If I want to find the values of x for which f of x equals 3, so that's my y value, notice that I'll highlight that 3 in yellow, okay? Notice that it's going to touch the graph not once, but twice. So based off of part A, we already know that one of our answers for x has to be 4. But if I look then on the left-hand side, it looks like it's not, once again, going to be a nice whole number, or integer, I guess, but it is going to be a decimal. And it looks like this one is pretty much in between. So I was thinking that would be then negative 3.5. All right, finding the domain. Going from the left to the right, I see that over here on the left, I have an open circle. That looks like that is at negative 4. So I need to have a parenthesis there. If I go all the way over to the right, I see I have a closed dot over here at 1, 2, 3, 4, 5, 6. So I need a bracket there, and there's my domain. The range going from the lowest to highest, well, the lowest looks like it is at 0. It is a closed dot, so I'm going to have a bracket. The highest up is 1, 2, 3, 4, 5, 6, where I have that horizontal line. It's including, so we'll have a bracket. In part E, there only looks like one x-intercept, and that happens to be at the ordered pair 6, 0. And then it looks like I only have one y-intercept, and that is up at 0, 6. So pause the video, see if you can do the checkpoint problems here. So I want you to identify domain, range, x-intercepts, y-intercepts, and evaluate f of 1 with both of these pictures. So with number 1, we should have gotten our domain to be negative 2, 1, and it's both in brackets. My range goes from 0 to 3, both in brackets. My x-intercept, there's only one of them. It's at the ordered pair, negative 2, 0. We have one y-intercept. That's at the ordered pair, 0, 2. And when I'm looking at f of 1, it looks like when I have 1 for x, I have 3 for y, so 3. For number 2, for part A, my domain goes from negative 2 to 1. Negative 2 is not included and 1 is, so we got parenthesis followed by a bracket. For my range, I go from negative 1 to 2, where negative 1 is included, so it's a bracket, and 2 is not, so it's a parenthesis. Both my x and y intercepts are at the origin, so 0, 0. And f of 1 looks like it's at negative 1. So that's us obtaining information about a function from a graph, identifying domain and range from the graph, and identifying intercepts from a function's graph.